here we're told to simplify, and we have a bunch of rational exponents. So we can go ahead and use the exponent laws to simplify this. If we have x to the power of 1/2 times x to the power of 1/3 divided by x to the 2/3, remember that when we multiply powers of the same base, we add the exponents. So this is equal to x to the power of 1/2 plus 1/3. And I'm dividing by a power of the same base, so I can subtract that exponent. So I have minus 2/3. Well, this is just equal to x to the 1/2 minus 1/3, because 1/3 minus 2/3 is negative 1/3. So I have x to the 1/2 minus 1/3. Well, I have to find a common denominator, so I can write this as 3/6 minus 1/3 is 2/6. So I have x to the 3/6 minus 2/6. So this is equal to x to the 1/6. And I could write this as a radical. I could write this as the 6th root of x if I wanted to. But you can leave it as a fractional exponent. In B, we've got y to the 1/4 to the power of 2 times y to the power of 3 to the power of 1/2. So the first thing is to simplify the exponents. I'm raising a power to a power, so I can multiply the exponents. 1/4 times 2 is 1/2. So I have y to the power of 1/2. 3 times 1/2 is 3/2. So I have y to the power of 1/2 times y to the power of 3/2. When I'm multiplying powers of the same base, I add their exponents. So I'll have y to the power of 1/2 plus 3/2. Now, 1/2 plus 3/2 is just 4/2. So this is just equal to y squared. In the next example, we have 5x to the 1/2 squared. So times 6x to the power of negative 3/2. So the first thing that I would probably do here is I'd probably square 5x to the 1/2. Now, since 5x to the 1/2 is in brackets, I'm going to square each of these factors. So I'm going to square 5, and then I'm going to square x to the 1/2. So I get 25 times x, because x to the 1/2 squared is just x. Next, I've got to multiply that by 6, x to the minus 3/2. Now, I don't raise 6 to the exponent 3/2 because it's not in brackets here. So if I would have brackets around the 6, if I would have brackets like that, then this would mean 6x to the power of negative 3/2. But since there's no brackets, I just raise x to the exponent negative 3/2. So let's go ahead and now we can simplify this. I can multiply the coefficients here. 25 times 6 is equivalent to 150. And if I raise x, if I multiply x times x to the negative 3/2, I add their exponents. So I have x to the power of 1, x to the power of 1 plus negative 3/2, which is just x to the power of 1 minus 3/2. This is equal to 150 x to the power of minus 1/2. And to write this with a positive exponent, I could write this as 150 over x to the power of 1/2. And again, this negative 1/2 exponent does not apply to the 150. It only applies to x. So again, if I would have wanted to, I could have written this in radical form. And I could have written this as 150 over root x. And then I could have rationalized the denominator by multiplying both the numerator and denominator by root x. So this is equivalent to 150 root x over x. But I would probably just leave this as a positive exponent. In example D, we've got something a little bit different. We've got the ratio of two, or we've got the quotient of two radicals. So here I've got the fifth root of x squared divided by the cube root of x to the power of 4. And we're going to try to simplify this. So in order to simplify this, I can rewrite this using the exponent laws. I can write the fifth root of x squared as x to the power of 2 over 5. And I can rewrite the cube root of x to the power of 4 as x to the power of 4 over 3. So this is equivalent to x to the power of 2/5 minus 4/3. When I'm dividing powers of the same base, I subtract their exponents. Now I need to find a common denominator here. So I can write this as x to the power of 6 over 15 minus 20 over 15. And 6 to the 15th minus, or sorry, 6 over 15 minus 20 over 15 is equal to minus 14 over 15. To rewrite this with a positive exponent, I can write this as, I can take the reciprocal, and write this as 1 over x to the power of 14 over 15. And as a radical, this is equal to the 1 over the 15th root of x to the power of 14.